Hello everyone and Assalamualaikum. Today in this video we are going to be presenting about application of determinants. Before we started, I'm going to introduce you to our group member, which is Safiya, HAMIDAH, WAFAA and BATRISYA. Before we started,
a determinant is a scalar value that is calculated from the elements of a square matrix, meaning a matrix with the same number of rows and columns. It provides important information about the matrix, such as whether it is invertible or singular. If the determinant is 0, the matrix doesn't have an inverse and it's called singular. If the determinant is non-zero, the matrix has an inverse and it's called non-singular.
In this case study objective, our objective is to provide a clear view of determinant concept and to show the proof in the mathematical theory. We are also going to develop a higher understanding on the concept using this presentation. We are also going to put up the example of the system equation for the case study and also to find how many grid line and one line notebook does the first customer buys based on our question. Now we are going to move on to our problem statement. A stationery store sells two types of notebooks. One, a one-line notebook costs RM1 each, and a grid-line notebook costs RM3 each. A customer buys some of each type of notebooks and spends a total of RM5 on the first day. On the second day, another customer buys two of the one-line book and two of the grid-line notebook for a total of RM6. How many notebooks of each type did the customer buy on the first day? For our second problem statement, we have a small repair shop offer 3 repair service, which is fixing screen, fixing batteries, and fixing buttons for each phone. Each service bring in money for parts, labors, and extra fees. The shop owner wants to know how many of each repair to do this week to match their monthly sales. They want to earn RM1 from parts, RM7 for labor, and they need to adjust RM4 extra that the same customer already paid before. So they must earn RM4 less in extra fees as they owe the same customer RM4. Fixing a
Next, Cramer's rule can only be used for systems where the coefficient matrix is non-singular. Next, if determinant of A is equal to 0, then the system of linear equation does not have unique solution. Cramer's rule cannot be applied. For homogeneous systems of linear equations, it is obvious that if the system have a unique solution, then determinant A for I equal to 0 for all value of I and for all value of I resulting in a trivial solution only. Next, for the Cramer's rule, consider the system AX equal to B. For step 1, we need to calculate the determinant A. For step 2, we need to calculate the determinant of A x1, which is we need to substitute the x1 column with B. Then for step 3, we need to calculate the x1, which is determinant of A x1 divided by determinant of
let's want to solve equation using Cramer rule. So first question we have 2 by 2. So the formula we want to find the x1 equal to the determinant A1 divided by determinant A. So first we want to find determinant E. We have to use formula AB minus BC equal to -4. So next we want to find determinant A1 is AD minus BC equal to -8. So we want to find x1. We have to divide -8 divide -4. So we get x1 equal to 2. So next we want to find determinant E2 equal to -4. So we want to find the x2 is -4 divided by -4. So we get 1. So the solution x1 equal to 2 and x2 equal to 1. So we just input into the equation, so we get the right answer. So that's means the solution is correct. So next we have question 3 by 3. by t are the simplest formula to find the x1 equal to determinant A1 divided by determinant A. So first we want to find determinant A only. We use the 3 by 3 formula, and then we get the determinant A equal to 12. And next we want to find determinant A1. We use the same step as the determinant A. So we get determinant A1 equal to 24. And then we want to find x1 equal to 24 divide 12, we get 2. Okay, next for the to find the x2, we first we have to find determinant a2 equal to 12, and 12 divided by 12 equal to 1, so we get answer x2 equal to 1. So next we want to find the x3, the last x, right? Okay, so first we have to find determinant a3, and then we get negative 48, and then we just divide it. Negative 48 divided by 12, so we get negative 4 for the x3. So that's for solution for the x1 equal to 2, x2 equal to 1, and x3 equal to negative 4. We just input into the equation, so we get the correct answer for the solution, the same answer for the solution, and then that is the correct solution for the S1, S2, and S3. So next we go to the next.
In conclusion, determinants and Cramer's rule are important tools in linear algebra that help us solve systems of linear equations in an efficient way. Determinants not only help us check if a unique solution exists, but they are also used in many real-world applications such as engineering, physics, and computer graphics.